Hello guys, this is Dr. Wu. Let me demonstrate Lab 2, the Catecholase-Catalyzed reaction. We know that organisms is a biological reaction happened quite frequently. For this type of reaction, there are two components. One is called substrate, another is called the product. The substrate is the one that the enzyme can work on and produce the result, which is the product. The role enzyme played in this reaction is to speed up this biochemistry reaction. For itself, it will remain the same before the reaction and after. The only change is between substrate and product. In today's lab, we use catechol, which is the substrate. Usually it's colorless, and react with oxygen under this enzyme catecholase and produce benzoquinol, which is the product. Then this product has the color. It's reddish brown color. As you see, the reaction happens. The color change from colorless to reddish brown. So we can use a device called spectral photometer to monitor the process of this reaction. In today's lab, there are two objectives. First is to familiar with this reaction here. Catechol react with oxygen and produce benzoquinol. The second, we use a spectral photometer to measure the reaction. We're going to use different concentration of the enzyme, which is catecholase. The hypothesis is that the more enzyme we add, the more product we will get, then the more absorbance value we will obtain. That is our hypothesis. So we'll test this hypothesis through today's lab. So next, let me do this lab according to the procedure, and then you will know how I got those data, and you can work on this data to finish those questions listed in the back of this lab. Now let's begin. First of all, let me demonstrate how to extract the catecholase from the fresh potato. Contains this enzyme. You can extract enzyme and then use to today's reaction. So I finished cutting. Now I will wait. I need 32 grams. So now 33, little bit more. And I use a blender to get the products to extract the enzyme. We got the extract of the catecholase. We just need to filter it. Use the cheesecloth. So here is the catecholase extract. Now we can do the next step. Label the 4 tubes with B blank, L low concentration, M mediate concentration, H high concentration. I will add the solution according to the table on page 3. First, add water. I will add 3 milliliters of water to tube B. last one is 0, no water in this tube. And the next reaction is to add the extract, the catecholase extract. First is 0, then the second one 20.5 meters. It's lower concentration. Then high concentration will be the third one. That's 1.2. Then the third one, high concentration, is 1, 2, 3 milliliters of extraction. And the last components we will add is this catechol. That's 1% catechol. I made it, use this as a substrate to see the reaction. 1, 2. Now you will see the color difference. So we can use the spectral photometer to get the result. Now let me turn this camera to another section of the lab bench. So now I got this result. We see the difference. So first of all, we'll use this machine. It's called the vertex mixer, just to mix the solution. So this one is a lower concentration, the mediate concentration here, than the high concentration. So we will record the absorbance value and to see the difference. So first of all, let me open this chamber, use the blank to calibrate the machine. Before we put in, we use a skim wipe to wipe the outside of the cuvettes. This is called cuvettes. So there's a chamber here you can put in and adjust the 0. Okay, then 0 the machine is first step using this blank, which contains no enzyme. Then we use the air, transfer the solution from the tube to the cuvette, because the cuvettes only feed this chamber. So the number changed. That's 0.18. So I will record this number here in this table. So the first one is 0 and the second one is 0.18. Okay. Let me get the result from the third one. The number here is 0.43. So we see this absorbance value increase. The last one is the one with a high concentration of the enzyme catecholase. The number is 0.75. So now I got all the reaction happened and record the color change. Now I can work on the graph here, how to draw a straight line reflecting the relationship between the volume of potato extract and the absorbance. As we know, absorbance the maximum is 0.75. So I will find the y-axis and marker the y-axis. Let's say this is one big square that represents 0.2, then 0.4, 0.6, and 0.8. That's my marker on the y-axis. Now I already marked this x-axis, which is volume of the potato extract from 0.5 up to 0.3. Let's put the first dot on the graph on this chart. And the first one is 0 and 0, so both are 0. Then the second dot is the one with a lower concentration. So lower, this is 0.1518. That's for close to 0.2. Then the concentration here, the volume is 0.5. So 0.5 and 0.18. That's first dot. And the next one, the concentration is the volume of extract is 0.15 versus 0.43, which will be here. 0.4 is here, 0.43 is, then the last one will be 3 meters of extract versus 0.75. So 0.7 is here, 0.75 is over here. Now we got these 4 dots. Then use the best fit line to express this relationship between volume of potato extract and absorbance. And this is how you finish the first question. Plug the volume of potato extract on x-axis versus the absorbance on y-axis in this graph. Now, with this information and the information from lab, you are able to finish the rest of the question, which is B, C, and D. If you have any questions, please email me. That's all for Lab 2. Thank you. Bye-bye.